Hello everybody, today we'll be talking about the package Beautiful Soup. Beautiful Soup is a Python library for pulling data from an HTML or XML documents, a process also known as web scraping. Quick definition of web scraping. Scraping is any act of copying data from the web to an external database or a spreadsheet. For example, copying a Wikipedia page to a Word document can be referred to as scraping. However, usually while talking about scraping, it is referred to automated scraping, hence pulling big sets of data from different webs or in regular times. Doing so saves you from the need to search, scroll, and click, and allows you to analyze more relevant information in less time. Common uses of scrapping are online price monitoring and price comparison, as the case of buying flight tickets, monitoring weather data, or tracking the online presence of a person. So Beautiful Soup, it allows the programmer both to pull data from various pages and then to navigate, search, and modify it by creating an easily readable praise tree. The name soup originated from a demeaning nickname given to the messy way in which HTML documents are built, not following standards order, and thus creating a soup of structurally incorrect HTML. Beautiful Soup was created in 2004 by Leonard Richardson, who is still the main contributor to this package. The main advantages of Beautiful Soup are that it is fast, it's extremely lenient, so it can work with very badly written HTML, and then it prettifies the code, allowing the programmer to later work with it on different packages as well. And the praise tree it creates understands the HTML in the same way the browser does. What we'll be covering: HTML web basics, Beautiful Soup commands, ethics of web scraping, and we'll have later an example. Documentation. If you want to install Beautiful Soup on your Python, you can easily download it like this. And if you want to include Beautiful Soup in an academic setting, in an APA style, it will be as the following. And now we'll move to Victoria.
Okay, so I will now first give you a little overview of some basic commands of Beautiful Soup, and also a little introduction into the structure of HTML web pages. When you want to scrape a web page, you first have to import the source code of the web page into Python. This can be done by using the request command, where you insert the URL of your web page. This will then display you the source code of your web page in Python. And here you can maybe already see why this package is called Beautiful Soup, because there's just a lot of information and a lot of, in this case, HTML text, out of which you have to identify where the relevant information for you is stored within this chunk of text. And so this is sort of the soup we're inspecting. For that, it is therefore quite helpful to have a little understanding of how web pages are structured, in particular how HTML web pages are structured. Usually they start with a head where you have like a page title and maybe font sizes and so on. And after that, usually we have the body and head, as well as other elements of the HTML text are identified using these tags. So for example, tags with H indicate headings, tags with P indicate paragraphs, tags with A indicate links, tags with UL indicate an unordered list, and then LI indicates the different list elements. And this is usually quite consistent. There's also other tags for other elements that can happen in an HTML web page structure, but you can also look that up online. What is good to know or important to know is that the tags can also have other identifying attributes. For example, here, my first paragraph is of the class intro, and my second paragraph is of the class main part. And there could also be an ID or other like attributes to make this tag more unique. Important to know as well is that whenever there is a tag that is within another tag, so for example, here I have this link, which is incorporated into the second paragraph tag, this is called the child of this previous tag. On the other hand, two tags who are on the same level are usually referred to as siblings. These tags will help us to identify the information that we are interested in our web page. What is quite helpful to know is the inspect command. Whenever you're on any kind of web page, you can right-click and go on to inspect, and then you will have this editor here, which shows you not only the HTML source code, but which also sort of lights up whenever you go over the corresponding part of the code. So that makes it easier to sort of narrow down where within the source code is actually the information stored that I'm interested in. But that is just a helpful hint to know. Now, using these tags, we can now identify the information we're interested in on the web page. And now I will introduce you a few commands that then help you to call this information. And soup in this regard refers to the source code as it is stored in an object in Python. And soup.title, for example, displays you the title of the page. Soup.body.contents displays you all direct children of the body. We could, for example, also do like soup head.contents, which would display all children of head, even though that might be quite uninteresting. And soup.findAll displays you all elements within the brackets. So for example, I asked to search for all paragraphs identified by P. So I get a list of all elements that are paragraphs in the source code. Soup.find is similar, but it only returns one result, namely the first paragraph of the source code. Now you can also narrow down the search a little bit more by, for example, searching for paragraphs of class intro. So this will only show you all paragraphs of class intro. You can also just search for other things, like, for example, the ID, or can search for all elements that are links and that contain the string Berlin. Another option is using CSS selectors. CSS selectors are fairly similar to the find all command, just that now you don't like write find all, you write soup.select. And again, very similar functions. It only has a slightly different syntax. So maybe it's good to know whether you use select or find all, because the syntax will be slightly different. And for example, here using select, you can also get displayed all links that are in the sort of in the body part of the HTML document.
Hi, I'm Sophia, and I'll be talking about the ethics of web scraping. Now, we showed you some very nice tools to perform web scraping, and you might be wondering, is this all legal? Well, web scraping per se is legal. However, you still need to pay attention to a few things, namely the type of data you're scraping and how you're scraping it. Scraping personal data. The rule of thumb is just don't do it. There are a few exceptions to this. So for instance, when you have explicit consent from the data owner, or if you're doing it for lawful reasons, which probably won't be your case, because an example of a lawful reason could be, for instance, public authorities scraping personal data for public interest reasons. So if you remember the Cambridge Analytica scandal, you'll have a good idea of what I'm talking about. Now, you can still get data from social networks, but to do that safely, you should use APIs. Now, I'm not going to get into detail of what APIs are and how they work, but API stands for Application Programming Interface. And this is basically a software that allows two separate pieces of software that are not designed to work together to communicate. You can find some useful resources on how to request and use APIs in these links that we provided you. However, getting APIs for social networks is very easy. You just need to Google API and the name of the social network you're interested in. Now, data protected by copyright. So you can still get into trouble even if you're not scraping personal data. So before performing web scraping, you should always check the website's terms and conditions and the robots.txt file before scraping a website's data. The robots.txt file, which we'll see in a second, can be easily accessed by just adding robots.txt at the end of a URL. So for instance, if we look at Wikipedia's terms of use, we can see that they clearly state that you are free to share and reuse their articles and other media under free and open licenses. So Wikipedia is probably the safest way to go when you want to perform web scraping. However, that's unfortunately not always the case. In fact, a website might explicitly forbid you to scrape their data. If we look at, for instance, Facebook's robots.txt file, we'll see that right at the beginning of a very long file, which you can check yourself. Here, we just have a tiny example. You'll see that they say that collection of data on Facebook through automated means is prohibited unless you have express written permission from Facebook. And this may only be conducted for the limited purpose contained in said permission. And here we just have a tiny example of basically a list of actions that user agents are not allowed to perform. So for instance, here we have Applebot, and we see a list of data that Applebot is not allowed to scrape. And now I will hand the floor to Satana, who will.
So let's take a look at an example of how we can use Beautiful Soup. I'm going to be scraping information on COVID testing and travel restrictions here in Germany from the US Embassy website. So we're going to start by importing the libraries that we need, starting with requests. This initial command imports the requests library, which makes doing HTTPS requests in Python much simpler. From there, we're also going to import the Beautiful Soup library. So now that we have the relevant libraries, we can set the route. Like I said earlier, we're going to be pulling information from the US Embassy website. Next, I'm making an HTTP GET request to this URL, basically grabbing the page content, and then we're going to use Beautiful Soup to parse all of the HTML. When we use Beautiful Soup here, we're parsing the HTML from the request object, which creates a Beautiful Soup object that then allows you to call certain methods and lets you sort through the parsed HTML. The next 3 lines of code grab the pieces of HTML from our soup. We're basically going to be grabbing the sections from the tags with the relevant IDs. To find this, we can just go on to the web page, right-click, click Inspect Element, and then take a look at what areas we want information from. This tells us the IDs that we should be looking at. So we use soup.find here, since find returns the first thing that matches your request. So now, let's print out the HTML code inside of the section tag so that we can identify what information we specifically want to scrape. We can look through each section and determine what information is relevant. Here I'm also going to use prettify so that the HTML code is a little bit easier to read. So taking a look at the website, I've identified 3 sections that I want information from: testing, vaccinations, and travel information. I can see here that each section looks like it's organized by a heading followed by bullet points. Using that information, I can go in and find these sections in the HTML code. So looking through this HTML here, we can see that we want the information that's in the H2 tag, and the HTML also tells us the class for this section, which is top title. We also find the unordered list, or UL tag, that has the bullet pointed information that we wanted to pull from earlier. So now we can use that information to create a general function to parse the data from the HTML. The soup_object parameter being passed to the function is one of my beautiful soup objects I parsed from the original HTML page. To grab the title from between the h2 tags, we're going to use the find function to get the correct tag with the class top_title. And then we use the getText function to return the text from in between the h2 tags. Next, we'll get a list of beautiful soup objects corresponding to all the UL tags in the document. These elements contain the text that we want in LI tags. Before we loop through the UL elements, we'll initialize an array where we can append the text in the loop. Next, we create our for loop to iterate through every UL element and their inner LI elements. When looping through every LI element, we use a getText function again to grab the text in between the LI tags. Then we append that text to our array. Finally, we return both the title and the text from the list elements. Now that we have our function, we're going to pass the three things that we want to our function. This will return the information that we want, which is the title and the text of each section as a list. Finally, we can print to see the information that we scraped. And there you go. Now you have all of the information that you wanted successfully scraped. So while this is just one example of the possibilities of beautiful soup, like we covered earlier, web scraping has a number of applications and can be used as a great tool in data analytics when used properly.